Hey everyone, welcome to the first lesson of Unit 5 in Math 2. This unit, before we begin, this unit is all about solving quadratics. In other words, you should know how to solve an equation that's linear in nature. So if I asked you to find 3x plus 5 equals 4, for example, you should be able to solve for x in that equation just fine without any problems. Any type of equation that is linear. So maybe something like this. Something like that you should be able to solve. It's a linear equation. Why is it linear? Because the highest exponent is 1. The highest exponent on the x is 1. Well, this year, our focus is on quadratics. We've already talked about how to manipulate different types of quadratics, graphing quadratics, and the whole bit, factoring, converting to vertex form, standard form, and all of that. But now we're going to focus on how to solve quadratics. And so how do I know that I'm solving a quadratic? Well, when the equation says something like this, 2x squared plus 5x minus 3 equals 7x plus 2. We know that this is a quadratic equation to solve because the highest exponent here is 2. So we're going to learn how to solve equations that have an exponent of 2 in them. That's our goal for today. But we're also going to see how it's related to the parabola, because we know that a quadratic, when the exponent is 2, we get some sort of U shape, some sort of parabola shape. So we're going to see how that's all connected in this unit and starting today. So with that said, let's go ahead and take a look at an example to help us understand this, to help us explore this a little bit. Our goal here is to graph this parabola. Now, we've done plenty of graphing in our time in Math 2, so this should not be a problem. We know it's a parabola. The first thing we have to find is our axis of symmetry. We do that by plugging in to x equals negative b over 2a, so that'd be negative 2 over 2 times 1. So that becomes 2 over 2, which is 1. So our axis of symmetry is x equals 1. Now we need to find our vertex, so we're going to do that by plugging the 1 back into the x. So that's 1 squared minus 2 times 1 minus 3. We simplify that by doing the exponents first. 1 squared is 1. And then carry everything else down. And then we multiply next. Well, the coefficient here is 1, so 1 times 1 is just 1. Negative 2 times 1 is negative 2. And then simplifying from there, so we get 1 minus 2 is negative 1, minus 3 is negative 4. So my vertex would be 1 comma negative 4. That's my vertex. Now we're going to take that and we're going to graph that on a coordinate grid. And so when I do that, I start to the right 1 and down 4. And I'm going to follow my normal slope pattern of 1, 4, 9. So I'm going to go up 1, right 1. And then from the vertex up 4, right 2. And then up 9, 2, 4, 6, 8, 9 over 3, and so on. Then we reflect it to the other side. And we have our parabola. So this is a very basic review problem that we've been doing for a long time in Math 2, but we're going to see how this is all related to solving quadratics. Now you should recognize that, remember, we can find the y-intercept really easily. Remember, the y-intercept is found in the c value. The y-intercept in this case is 0, negative 3. Because the c value is negative 3. And we can verify that here because we went down 3 for the y-intercept, so that makes sense, okay? So we've graphed it, there's that. The next thing it says to do is say, what are the x-intercepts? Well, remember, the x-intercepts are where the graph crosses the x-axis. So here's my x-intercepts right here and right here. So we can see that our x-intercepts are negative 1, 0, that's this one, and 3, 0, that's the other one, okay? Those are my two x-intercepts. And then the last thing it wants us to do is to factor the quadratic. So I'm going to put my graph off to the side for a second, and I'm going to factor this guy. So it's y equals x squared minus 2x minus 3. We're going to factor that. So remember, we look for GCFs first. There is no common factor other than 1, so we're going to go straight into our x factoring, or quadratic factoring. A times c is negative 3. 1 times negative 3 is negative 3, and then b is negative 2. So we have to list our factors of 3. The only one that works is 1 and 3. So we put a 1 here and a 3 here. Now we look at the signs. Well, if I wanted to multiply to negative 3, that means one of these has to be negative. If I wanted to add to a negative number, that means the bigger number has to be negative. And then from here, we'll expand this out. So this will say x squared plus 1x minus 3x minus 3. And then we'll factor by grouping. So the GCF out of x squared and 1x is x. Left over is x plus 1. The GCF out of negative 3x and negative 3 is negative 3. Left over is x plus 1. So my factors are x minus 3 and x plus 1. So that's the equation in factored form. So here was standard form. This is factored form. Okay. Now with that said, the question here, as we identify these things, you guys should be able to see, again, that our x-intercepts were negative 1, 0, and 3, 0. So I have that written down. And I have my graph here, and I have my factored form here. Well, what do we notice is a relationship? That's really what we're trying to get at here. What do we notice? We should notice that the factors that we have, the x minus 3 and the x plus 1, have the same numeric values as our x-intercepts. That is the purpose of factoring. That's why we spent so much time learning how to factor, because it's related to finding the x-intercepts of a parabola. Now, it goes a lot deeper than that. When we go to solve equations, we need to know how to factor for other reasons. But this is a main application, a main concept that we need to grasp, that when we are factoring, that is helping us find the x-intercepts. And that's kind of where solving goes from here, okay? So I'm going to want to have you write this down. So there's our factored form here. In your notes, you're going to want to write this down. It says the x values of the x-intercepts can be seen in the factored form. Again, here is our factored form, x minus 3 times x plus 1, or written x plus 1 times x minus 3. We can see that our x-intercepts from the graph were negative 1, 0, and 3, 0. So we see the 1 here. We see the 3 there. There's a relationship there. We'll get more into that relationship in just a second. So that's the first thing you need to notice. The second thing I want you to notice is that the x-intercepts, and we knew this, but I'm going to hound it today because we're going to use this. The x-intercepts are when y equals 0. So we notice that y equals 0. When y equals 0, we have our x-intercepts. Going back to the graph, we can see that very easily, right? The y value at these points is 0 because I didn't go up or down. So our x-intercepts are there. Just like our our y-intercept is right here. Our y-intercept is 0, negative 3 because it's when x is 0. So our x-intercepts are when y equals 0. Our y-intercept is when x equals 0. All right, let's go ahead and go on to the main purpose of this lesson. The zero product property. This is going to help us solve quadratics in a nice way. Okay, the zero product property basically looks like this. If the product of two numbers equals 0, then one of those numbers must be 0. What does that mean? Product means multiply. So when I multiply two numbers together, any two numbers, if I multiply two numbers together and the end result is 0, that means that one of those two numbers must be 0. That just makes sense. If A times B equals 0, then that means either A is 0 or B is 0. That's the only way you get 0 when you multiply numbers. It doesn't work otherwise, okay? So let's kind of explore this a little bit. You don't have to write this part down. Oops, as I draw over my lesson here. You don't have to write this part down, but I do want you to write the zero product property and all the blue stuff, okay? But let's take an example. If I'm multiplying two numbers and it equals 0, if the first number is 5, what must the second number be? The second number must be 0. Well, what if the second number is 42? What does that mean for the first number? The first number must be 0, right? One of those numbers must be 0 in order to, when you multiply them, get 0. That doesn't work in everything in life. We can't say, okay, a number times a number equals 7. So that means one of the numbers is 7? No, that's not true. One of the numbers doesn't have to be 7 just because the product is 7. But 0 is very unique. If I multiply two numbers together and the result is 0, one of the numbers has to be 0. Well, let's take this a little bit further now. Let's say I have 0 there. If 0 is the first number, what could the next number be? Well, the next number could be any number that you want. It doesn't matter what it is because 0 times anything is 0, okay? Same thing the other way, we can flip it around. Now, here's where it gets fun. Here's where the purpose is. What if the first number that I'm multiplying is x minus 7? What if the first number was x minus 7? If I had x minus 7 times some number and we equal it to 0, okay, that means either this first number is 0 or this second number is 0. Well, let's assume that this second number is not 0. That would mean that the first number is. So we would say that this x minus 7 must equal 0, right? If this one isn't 0, if this line is not 0, then this line, has to be 0. So that means x would equal 7, and we solve that equation. So that would be one solution. Doesn't matter what the other one is. Now, what if we go the other way? What if we go the other way? What if we said the second term, the second number is 3x plus 8? Let's say this one was 3x plus 8. Well, it doesn't really matter what's in this box. If this box isn't 0, this one must be. So we would solve that equation. We'd say 3x plus 8 must then equal 0. And then we'd solve that like we normally would. We'd subtract 8 from both sides. We get 3x equals negative 8. And then we would divide by 3, so we get x equals negative 8/3. Okay? Now, with that said, it wouldn't matter what the other one was. Now, if I put those together into one complete statement, it would look something like this. Let me minimize this a little bit so we can see it. It would look something like this. If x minus 7 times 3x plus 8 equals 0, right? So we are multiplying this term times this term, and we're getting 0. That means either the first term is 0 or the second term is 0. So we set the first one equal to 0, and we got 7. We set the second one equal to 0 here, and that's where we got negative 8/3. So that means x could be one of two answers. It could be one of those answers is true. So we say both of them. X is 7 or it's negative 8/3, one or the other, okay? How does that relate? How does that relate back to our graph? Well, when I go to solve these things, notice I got two solutions here. I got two solutions. Well, how many x-intercepts do I have? In this case, I have 2 x-intercepts. That goes together. I have a parabola that has 2 x-intercepts, just like I have an equation that has 2 solutions. Why do I have 2 solutions? Because this is a quadratic. The highest exponent is x squared, so we would assume that we would get 2 solutions. Now, that's not always the case. We can sometimes get 1 solution or 0 solutions. We'll talk more about that later on. But our solutions in this case would be 7 and negative 8/3. Let's go ahead and write this down. This is very, very important for you to work with here. We want to solve by factoring. I'm going to give you a bunch of steps, okay? Here's the example that we're going to work with. And so maybe you want to write this down. Notice I left a gap here. So I'm going to have the process up here, and then I'm going to have the example here, okay? When you go to solve a quadratic, and we know that this is quadratic because the highest exponent is x squared, the first thing we want to do, step 1, is to move all the terms, everything over to one side so that it is equal to 0. That way we can apply the 0 product property. And so we have, in this case, we have 2x squared plus 3x equals x squared minus 5x minus 7. Now we can move everything over to the left of the equal sign or everything over to the right of the equal sign, but here is a big, huge hint for you. It should make your life easier. We want to try and make the x squared have a positive coefficient. So we could subtract 2x squared from both sides, but we'd end up with a negative x squared on the right. We don't want that. We want a positive x squared. So what we're going to do is we're going to subtract the x squared to both sides. That will get rid of the x squared on the right-hand side. We want to move everything over to the same side. So we're going to get rid of the negative 5x and the negative 7. So we're going to add 5x to both sides. And we're also going to add 7 to both sides. Okay? Well, what do we get? 2x squared minus x squared is 1x squared. It's just x squared. 3x plus 5x is 8x. And then we have no constant plus 7, so that's plus 7. On the other side, we end up with 0. That all cancels out. And so there we've done it. We've moved everything over to one side. It equals 0. Again, subtracting x squared adding 5x and adding 7 to both sides gets everything over to one side. Step 2, once you have that, is to factor what we have. Now we have a quadratic here. We know how to factor. We go through the process of factoring. So we do our x, a times c on the top, b on the bottom. Find our factors of 7. The only factors of 7 are 1 and 7. Because 7 is positive, that means these are either both positive or both negative. Since that's positive, they're both positive. Then we go through and expand, equals 0, and then we group. So the GCF there is x times x plus 1. The GCF there is 7. The leftover is x plus 1. And then our factors would be x plus 7 times x plus 1. And that's still equal to 0. So there, I factored it. I got x plus 7 times x plus 1 equals 0. That's step 2, factor the quadratic. Step 3 is to apply the zero product property. Remember, the zero product property said a number times a number, if it gives you 0, that means one of these numbers is 0. So if this was a and this was b, we would say either a equals 0 or b equals 0. That's what the zero product property says. Well, in our case, notice that we have two things that we're multiplying. We're multiplying this parenthesis times this parenthesis, and we're ending up with 0. So we can apply the zero product property. What is the first term here? Just like a was the first term, the first term here is x plus 7. So we'd say x plus 7 equals 0. Or the second term, b, is going to equal 0. So the second term here would be x plus 1 equals 0. And then from here, we would solve each one of these. So we would subtract 7 from both sides. On the first one, we get x equals negative 7. And on the second one, we would subtract 1 from both sides. We'd end up with x equals negative 1. So our solutions we would write as negative 7 or negative 1. You can see how important it is that you have a good foundation with what we learned first semester. We have to know how to factor. And in fact, we have to get to the point where we're factoring pretty efficiently, pretty quickly, okay? So there's that. We use the zero product property. And then we solve each one of those equations. And we have our two solutions, x equals negative 7 or negative 1. Okay, so make sure you have this written down in your notes really detailed, really well, because you're going to refer back to it as a help as you go through this. All right, with that said, let's go ahead and do some practice problems. You guys go ahead and pause the video and do it on your own and see what you come up with, and then come back and push play and compare yours to mine. For number one, we have x squared minus 6x equals negative 5. The first step is to make everything equal to 0. So since I already have the x squared and the minus 6x on the left, I'm going to move everything else over to the left. So I'm just going to add 5 to both sides. Now notice 5 is not a like term with negative 6x, so I don't want to combine those. I'm just going to rewrite it next to it. So we'd say x squared minus 6x plus 5 equals 0. Did step 1. Step 2 now is the factor. And I'm not going to go through the big long process of factoring. You guys should have already done that. The factors are going to be negative 5 and negative 1, x minus 5 and x minus 1. And if you need more help with factoring, please make sure you ask me for that help when you need it, okay? Next time we meet. The next thing we do is apply the zero product property. So the first term, x minus 5 must equal 0, or the second term, x minus 1 must equal 0. From here, we'll just solve them. So here we're going to add 5 to both sides. So we end up with x equals 5. And then here we're going to add 1 to both sides. So we end up with x equals 1. And so our answers are x equals 1 and 5. That is our solutions. So the point is this. If I plug in 1 to x, I should end up with negative 5. These sides should be equivalent. If I plug in 5 to x, to both x's, I should get something that's equivalent. So let's try it. 5 squared is 25. Minus 6 times 5 is 30, so 25 minus 30 is negative 5. If I plug in 1, 1 squared is 1. Negative 6 times 1 is negative 6, so 1 plus negative 6 is negative 5. So both of these are solutions to this equation, this quadratic equation. For number 2, we have 8x squared minus 60 equals 28x. So we're going to move everything over to one side. In this case, I'm going to move it to the left again. So I'm going to subtract the 28x. And again, I can't combine those. Remember, when you write things, you want to write them in standard form. So it'll say 8x squared minus 28x minus 60 equals 0. So I got everything equal to 0. Our next step is to factor. Now remember, this one is pretty gross. This is a pretty big factor, okay? This one, number 1, was easy because the coefficient in front of the x squared was just 1. But this guy, we got some big numbers here. So remember that we always want to look for a GCF first. Let's look for a GCF. Well, a GCF out of 8, 28, and 60 is 4. We can't take out an x out of all of them because they don't all have an x. So let's figure out what's left over. 4 times 2x squared minus 7x minus 15. If I distribute that, I'll get the 8x squared minus 28x minus 60. Now I'm going to go through the factoring because these are bigger numbers here. A times c would be negative 30. B would be negative 7. So listing my factors of 30, I got 1 times 30, 2 times 15, 3 times 10, 5 times 6. Well, we recognize that the 3 and the 10 make up negative 7. To make a negative 7, we would need the 10 to be negative and the 3 to be positive. And then positive 3 times negative 10 is negative 30. So then we expand this. This will say 2x squared plus 3x minus 10x minus 15. Then we group it. The GCF on the first one is just x. The leftover would be 2x plus 3. The GCF on the second one, remember there's a negative there, so we're going to take that out. The GCF out of the 10x and the 15 is 5. So the leftover would be 2x plus 3. Because these match, we did it right. So our factors are x minus 5 and 2x plus 3. And remember, we still have that 4 that we factored out earlier, so we're going to carry that down. And we got it equal to 0. The next step, step 3, was to use the zero product property. Now, in this case, the zero product property, how many things are we multiplying here? We're actually multiplying 1, 2, 3 terms, 3 things that ultimately end up equaling 0. That means one of those 3 things must be 0. So up here, we only had 2 terms that were multiplying to equal 0, so we had 2 equations. Down here, we have 3 things that are multiplying to 0, so we should have 3 equations. Our first equation is going to be 4 equals 0. Our second equation is going to be x minus 5 equals 0. And our third equation is going to be 2x plus 3 equals 0. And then we solve each one of those. Now we look at this one, the 4 equals 0. That's a nonsense statement. 4 doesn't equal 0. This is invalid. There is no x value that will make this true. So we don't have to worry about this one. This one we can cross out. Okay. For this one, we're going to add 5 to both sides. So we end up with x equals 5. For the last one, this is going to be a multi-part one. We're going to subtract 3 from both sides. So we end up with 2x equals negative 3. And then we're going to divide by 2 on both sides. And so we would get x equals negative 3 halves. Or we could write that as, if you wanted to, negative 1.5. So our solutions here, there was none for this one. Our solutions are going to be x equals negative 3 halves and 5 for this, okay? Now, you can expect, but again, it doesn't always happen. We're going to talk about that more in the future. You can expect that you're going to get 2 solutions. You might get 1, you might get 0. We'll talk more about that later. But you're definitely not going to get 3 or 4 or 5 different answers when your highest exponent is a 2. You'll get at the most 2 solutions, and that's what we have here, okay? So that is how you solve by factoring, solving quadratics by factoring. And so we can see we got that right. So let's go on to the next thing here and see how this applies a little bit more to our graphs. Here it says, determine the x-intercepts of a parabola represented by the equation y equals x squared minus x minus 6 using analytic methods. Well, before we get into the analytic methods, let's go ahead and look at the graph of this. And I'm not gonna dwell a whole long time on the graph of this equation, but I would say x for the axis of symmetry, x equals negative 1 over 2 times 1. This is going to get gross because we're going to get a fraction here. Our axis of symmetry is 1/2. And then we'd have to plug that in to find our vertex. We would get 1/2 squared minus 1/2 minus 6. This gets gross. We got 1/4. 1/2 times 1/2 is 1/4. Minus 1/2 minus 6. We have to get common denominators there, or put it in decimal form. We could do that. 1/4 is 0.25. 1/2 is 0.5. So 0.25 minus 0.5 is negative 0.25. Minus 6 is negative 6.25. So my vertex is going to be 0.5, the 1/2 is 0.5, comma negative 6.25. And then from here, when I go to graph it, it gets really gross because I got to go to the right 1/2 and then down 6 1/4. That gets really weird. And to follow a slope pattern after that makes it a little bit more difficult. So this example is not a good example to graph and then find x-intercepts. That's why it's telling us to solve it analytically. So let's go ahead and solve it analytically using the methods that we just learned. Remember from the previous slide, from the first slide, let's go back to that for a second. The very first slide that we talked about, we said, notice the x-intercepts are when y equals 0. The y-intercept is when x equals 0. So let's go back to our problem here and see what we can do with this. We've got y equals x squared minus x minus 6. Well, let's go ahead and find the y-intercept first. Now, you guys should know that the y-intercept is just 0, negative 6, because we can see that in the c value. But why was that? We talked about that before. That is because the y-intercept occurs when x equals 0. So what we do is we plug in 0 for x. So we end up with 0 squared minus 0 minus 6. Well, 0 squared is 0, minus 0 is 0, minus 6 is negative 6. So we can see that our solution here is negative 6. So our y-intercept is 0, negative 6. Okay? The point is, yes, you could have identified that without the work. But I wanted you to see something. The y-intercept is when x equals 0. Therefore, the x-intercepts are when y equals 0. It's the opposite, when y equals 0. So what does that mean? We set y equal to 0. That'll say 0 equals x squared minus x minus 6. And now we solve this equation, just like we solved that one. Well, not just like it, because this was easy. Notice what we have here. We have a quadratic. How do we solve quadratics? We go through the motions. First step, make the equation equal to 0. Well, it already is. We set y equal to 0. It's already equal to 0. The second step is to factor. So I'm not going to go through the long factoring again. The factors in this case are going to be x minus 3 and x plus 2. The third step is to use the zero product property. So we set each one of these terms equal to 0. So we'll say x minus 3 equals 0, or x plus 2 equals 0. And so we end up with, when we solve for x, we add 3 to both sides, we get x equals 3. When we subtract 2 from both sides on this one, we get x equals negative 2. So those are the solutions to this equation. Now we write them as x-intercepts, as coordinates. So the first coordinate would be 3, 0, and the second coordinate would be negative 2, 0. And so those are our two x-intercepts. Now, if we went back to the graph and actually, graphed it carefully, we would see, by verifying this, we would see that we actually do have x-intercepts of negative 2, 0 and 3, 0. We had a y-intercept of 0, negative 6, so that was down here somewhere. And then here was my axis of symmetry. This is not drawn to scale at all. But now we can get an idea of what that graph looks like pretty accurately. Even though the axis of symmetry is gross, we can graph a parabola using the intercepts. That makes a different method if something else gets more difficult, okay? So let's go ahead and take a look at the actual graph there, see what we have. Again, y-intercepts are when x equals 0. So we set x equal to 0 and solve for y. The x-intercepts are when y equals 0. So we set y equals 0. And then we have to use our quadratic method by factoring and the zero product property. And we get our two solutions of 3 and negative 2. and then we write those as coordinates, 3, 0, and negative 2, 0. And then if we go to graph this, now my graph may not show everywhere, everything that we need, but we know that we have x-intercepts of negative 2, 0, 3, 0, a y-intercept of 0, negative 6, and we can kind of connect the dots there and see our parabola. Okay, and now we can see our axis of symmetry here is actually right where it should be, right in the between 0 and 1, 1/2. Okay. All right, with that said, here's one more that I want you to try on your own. And when you're done, come back and compare your answer to mine. Go ahead and determine the x-intercepts and the y-intercept of this parabola. Now, this might be a little bit tricky because we have fractions involved, but we'll go over it once you get stuck. Okay. All right, for this one, we've got y equals x squared minus 17 over 2x plus 4. And we are trying to find the x and y-intercepts. Well, again, the y-intercept should be pretty easy to do. The y-intercept is going to be 0, 4, because our c value is 4. Our x-intercepts are, remember, when y equals 0. So we'll set y equal to 0. It says 0 equals x squared minus 17 over 2x plus 4. The next step is the factor. Now, factoring gets kind of gross here because we have fractions. So I'm going to show you a quick trick, not a trick, but a good mathematical practice whenever you see fractions. How do we get rid of fractions? Well, fractions are just a result of division. That's all a fraction is, it's division. How do I get rid of division? I multiply. So if I want to get rid of dividing by 2, I'm going to multiply by 2. And remember, whatever I do to one side, I have to do to the other. Now, the convenient thing here, and this is why I call it a trick, is that 0 times 2 is 0. So that didn't change anything on that side. On the right side, 2 times x squared is 2x squared. We have to distribute here. Negative 17 over 2x times 2 is negative 17x. And 4 times 2 is 8. This is a bit of a challenge problem, just so you guys know. But from here, you should be able to do it. We've got it equal to 0, so our next step is to factor. The top number would be 16, the bottom number would be negative 17. The numbers at work here are going to be 16 and 1, both of them negative. Then we expand, so we have 2x squared minus 16x minus 1x plus 8. And then we group, so the GCF there is 2x, and then times x minus 8. The GCF on the second one is just a negative 1. The leftovers would be x minus 8. So my factors are now 2x minus 1 and x minus 8, and that, remember, was equal to 0. From here, we apply our zero product property, so we'd say 2x minus 1 equals 0, and x minus 8 equals 0, and we solve each one of these. So here we add 1 to both sides, so we have 2x equals 1, and then we'll divide by 2 on both sides, so we end up with x equals 1/2. And then the next one, we would add 8 to both sides. And so we end up with x equals 8. So these are the solutions. Our x-intercepts have to be written as coordinates. We would write it as 1/2, 0, and 8, 0. Those are our x-intercepts. Okay. Now, just to compare, make sure I'm good here. We have 1/2, 0, and 8, 0. Our y-intercept was just 0, 4. And then when we go to graph it, if we were very careful about our graphing, we would see that our solutions, our x-intercepts, actually work out. We have an x-intercept, oops, I'll get rid of that. We have an x-intercept of 1/2, 0, and another one of 8, 0. Okay? So I know that there was a lot here. If you guys have any questions, please reach out to me, come to tutoring, or ask me during our next Zoom meeting. I hope you have a good grasp, a decent grasp of being able to solve by factoring using the zero product property. If you don't understand something, ask for help, re-watch the important parts of this video, and remember to submit your notes, and I'll talk to you next time.